Personal finance practice problem using Excel. Rule of 72 and running balance calculation. Get ready to pursue personal financial fitness by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. We have the information on the left-hand side. We're going to populate that into the blue area on the right-hand side. We're going to look at the rule of 72, which is kind of a shortcut rule, and then we'll apply some other concepts, which will be some more precise and some have other benefits to them. So the information on the left says, assume the value of property is increased at a rate per year of 7%. How long before the property value doubles is going to be our question. So when we're thinking about something that's going to be going up, we're usually thinking about some kind of investment. It might be in like stocks or some kind of bonds and whatnot. And we're assuming then a rate of return at the 7%, or it could be in something like a home, which could appreciate in value, or property in that nature of land or something like that. Or we could be thinking about property such as if I was to purchase something, how much will the price of that thing go up over time if I was to purchase it a year from now, say from today? Obviously, if we were to purchase something today like a car, then it would be going down in value as it depreciates over time. So we're thinking about something that's going up. It's going up at the rate of the 7%. We want to think about when it will double. Now, we will think about an investment amount, which will just take $1,000 to think through it. But note that you don't even need the investment amount really to think about when it would double by applying basically the rule of 72 here. So that's what we'll start off with. We're not even going to consider the investment amount of 1,000. Now I'm going to go through the Excel fairly basically, fairly slowly, but this is not an Excel course, so I'll try to kind of go through it pretty slowly. But if you need more work on Excel, then practice just your Excel fundamentals here. So we're going to say I'm going to start off and I'm going to try to put these calculations into a table type of format. So the first number here we're going to put is the rule of 72. And I'm going to start off in the outer column. So in the outer column here, I'm just going to type in 72. That's going to be our starting point. And then we're going to divide into it. It's going to be 72 divided by the rate. But the rate should not be in the format of a percent, knowing that we can write the rate in the format of a percent or a decimal. So we got to basically say, okay, well, I'm going to take the rate here. And what I'm going to do is try as much as possible to take the information from the data on the left-hand side. That's just good practice when working in Excel. So I'm going to say this equals that 7%. Now note that now it doesn't have anything in here because this cell is not formatted as a percent. So I'm going to go up to the Home tab up top, which I'm going to be in all the time. So I'm not even going to go up to the Home tab after a while. I'm going to assume I'm in the Home tab unless saying otherwise. Then we're going to go into the numbers group down here, make this a percent. There's our 7%. Now, notice that you could make it a decimal. If I was to say, let's not make it a percent, undo the percent. Notice the undo is up here and just add decimals. It's the same number, but here's the decimals, number group, 2 decimals. What we would want to have it is I'm going to put it back in the percent, and then I want to multiply it times 100 here to give us just 7. That'll take it from a percent to just basically the number 7. So if I multiply this out, I'm going to say in this cell, I need to do an equation. Anytime I do an equation, I have to say equals, and then I'm going to point to the cells that I want to do something with. So I'm going to point to that cell right there, which is an E3, so equals point to E3, which is the 7%, times on the keyboard, the asterisk, times this cell right here, which is E4. So equals E3 times E4. That then is going to give us 7. Now, of course, I could make the 7 a percent, number group percent. That would be 700 now, but we don't want to make it a percent, so I'm going to undo that and just keep it at the 7. So then I'm going to go to font group and underline, and then I'm going to type down here our final result, which is going to be the years to double. How many years will it take to double? I'm going to divide the 72 divided by 7 by selecting equals, pointing to the 72 up top, which is in cell F2, and then divide that by 7, which is in cell F5, F5, and then enter. And we're going to get 10. Now that's rounded because I don't have any decimals right now. So once again, I'm going to go to the Home tab, number group, add a couple decimals. It could go past 2, but I'm just going to keep it at 2 decimals out. Notice that it's actually longer than 2 decimals but I'm going to round it to 2 decimals, noting that this cell actually has something that's not rounded in it if I use it to calculate something else, but I can only see up to 2 decimals at this point. That's kind of how Excel will work. So we're going to say, okay, it'll double in the 10.29 years. That's when we would expect this to be 2,000. If our investment was 1,000, we would expect it to be 2,000. So we can do that. That's a great little rule, but it's kind of abstract and it's obviously somewhat restricted to this idea of when something will double. So it's nice to know the actual valuation behind it as well. So now we're going to run a table and kind of think about this. Okay, well, if I made 7% a year, just logically, what would happen? And this format is something that would be difficult to do if we didn't have Excel, but with Excel or some other spreadsheet, Google Sheets or something like that, it's pretty easy to do. So let's kind of set this up and say, and it's really useful to have these kind of setups if you're really thinking through something. And like I say, the spreadsheets are free at this point in time. So these kind of shortcut rules are great if you need to do something, while you're under pressure. But if you're not under pressure, you could sit down at a computer or even with your phone these days, I guess. You could do this on an Excel worksheet, right? So I'm going to just put our numbers here. I'm going to say 1, 0, 1. I'm going to start at 0, 1, 2. Then Excel will know that that's a series. So I'm going to select this series of numbers, put my cursor on the fill handle down here so it looks like this, not like this, but like that. And then I'm going to grab that and drag it down, and Excel then should pick up the series down to 11. Now I'm going to stop at 11 because I happen to know that's when the doubling will happen, but I can go as far as I wanted to in practice. And then I'm going to go up top into the Home tab, into the Alignment group, and center that. So there's going to be our starting point. Then I'm going to go into the investment over here, and I'm going to assume an investment of 1,000. So note, a question might say, hey, I'm not even going to give you the investment number. You're going to tell me when it doubles. But then I can always plug in an investment number, such as $1,000, and determine when it will double in a way that's probably more intuitive. So I'm going to say equals, and I'm always going to point to the investment in our data on the left-hand side whenever possible, because that's just good practice when you're doing scenarios. So I'm going to point to that, and then I'm going to multiply that times 7%. So obviously, if we did this with a calculator, if it goes up by 7%, it would be 1,000 times 0.07, 7%, would give us 70 plus the original 7, or 1,000 would give us 1,070 after year 1. Let's do that in Excel. So I'm going to say, all right, in Excel, let's go ahead and say this is going to be equal to, I'm going to pick up this 1,000 over here by selecting J2 and then say times, and I'm always going to try to pick up the data over here in our data tab, the 7%, instead of hard coding in or typing in 0.07. And say enter. There's our $70. And then the investment, this will be our running balance, will be equal to the prior $1,000. So I'm going to say equals J2, the 1,000 plus the I3, the 70. That'll give us 1,070. Now, I'm going to set this up so I can copy it down and make it nice and easy to do. But before we do that, let's go ahead and do that a few more times. So I can do that here. Now it's up to 1,070. And I would increase that for year 2 here by multiplying it times 7%. So I'm going to take this equals the 1,070 times the 7% again and enter. So it's a slightly higher rate of interest we would get because the investment has now been increased and it's compounding, as they say. And now this is going to be equal to the 1,070 plus the 75 and enter. And there we have it. Let's do it 1 or 2 more times. Do it a little bit faster. This equals the new number, 1,145, now compounded times the 7% would be an increased interest to $80, and then the total would then be the prior amount, 1,145 plus the $80. Let's do it one more time. We could say, okay, this is going to be equal to the 1,225 times the 7%. Enter. Then we'll add these up. Equals, whenever we do a function, it's going to be 1,225 plus the 85 and enter. Okay, so now I'm actually going to delete everything I've done here and try to do this the easy way so we can just copy this down. So I'm going to delete the whole thing. I'm going to select these. I'll keep the 1,000 up top, delete this. Let's do this 70 again so we can kind of copy it down. I'm going to take up that 1,000 and then say times the 7%. Now this 7% is not in the table. Anytime something is not in the table, you're typically going to need to make it an absolute reference whenever you copy it down. Let me show you what I mean by not doing that first. And so I'm going to say this equals the 1,000 plus the 70. Now, if I was to select these two and try to copy them down, I'm going to select both of them by highlighting them, put my cursor on the autofill handle and drag it down. Then you can see this one doesn't do what we want if I double click on it because it moved this cell down. So I want to tell Excel don't move that cell down, and I'm going to do that with an absolute reference. So I'm going to put my cursor back on these two, delete it, put my cursor back on the 70. That one in cell B3 right there, B3, I want to say, Excel, do not move that one down. Don't you move that one down, Excel. That's what we're telling it. And I'm going to select F4 on the keyboard. That puts a $sign before the B and the 3. That is not a $sign that means anything related to money. It's just kind of like code that tells Excel, do not move the cell down. Now, you only need a mixed reference, $sign, but I'm just going to use an absolute reference because conceptually it's easier kind of to figure out which $sign you need and whatnot. So I'm going to go ahead and say, okay. And now, if I was to select these two cells, put our cursor on the fill handle, drag it down, it looks like it does what we wanted. Let's double click on the 75 to double check that it does do what we want. We got the 7% times the 1,070. It looks correct. So that looks correct. So let's go ahead and highlight these two and drag it on down the whole way. I'm going to select these two and drag it on down the whole way. And there we have it. So there we have it. And you can see that that if I double click on this last one, it's still doing what we want pretty much. I still got the $signs right here, B3. That didn't move that cell down, but this other one did move down, right? And then these two moved down beautifully. So it all worked out perfect, just like we thought it would, just like we knew it would from the beginning had no hesitation that it wouldn't. So in any case, we're somewhere between years 10 and 11, right? We double right here. You can see it, and you can see this increase each year, and you get to see how the interest is compounding in this way. So this is a really useful way, especially if you don't really have a good grasp of how this compounding thing works, to kind of double check your work. And it's pretty easy to do in Excel, and it usually gives people a better understanding of what's going on. Let's try to do the same thing. Next time, we're going to do a similar process, but we're going to be using Excel formulas, and then we'll go to an actual mathematical problem to do similar kind of calculations so we can see how all these things tie together.